Hi friends, today we are going to speak about alternating current. In alternating current, let's have a circuit like this. This is a capacitor which is connected to an alternating power supply. The capacitance of the capacitor, let it be C. The voltage that we are giving over here, it's an alternating voltage, and this voltage is V is equal to V0 sine omega t. We'll have to formulate the relation for current. And in this case, be careful. In this case, we have to formulate a relation between voltage, capacitance and current. Therefore, we cannot use the Ohm's law. Therefore, we have to recall one expression, that is, as we all know, I is equal to dq by dt. That is, current is the rate of flow of charge. And we also know that Q is equal to CV. From the basic expression of capacitance, we know Q is equal to CV. If we are clubbing these, we will get I is equal to d by dt of CV, where V is V0 sin omega t. Therefore, I could write d by dt of CV0 sin omega t. In differentiation, we could take the constants out, that is, I is equal to C and V0, they are constants. We could take it out. Then d by dt of sine omega t. As we are differentiating d by dt of sine omega t, we will get cos omega t into omega. It's differentiated in the function of a function format. Therefore, I is equal to CV0. The answer for this differentiation is omega cos omega t. Okay, then I could write this as I is equal to CV0 omega cos omega t, in which if we are analyzing in this equation, the maximum value of current will be CV0 omega. Since this is the constant term in this equation, the current will have a maximum value like this. That means I could write the peak value of current or the maximum value of current in this equation will be CV0 omega. We could rewrite this equation as I is equal to I0 cos omega t. But by having an equation of V is equal to V0 sin omega t and I is equal to I0 cos omega t, we cannot draw the phasor diagram. We have to convert this cos omega t into a function of sine. For that, we all know sine 90 plus theta is cos theta. Therefore, sine theta plus 90 is also cos theta. Therefore, I could write sine omega t plus pi by 2, it will be cos omega t, or cos omega t is equal to sin omega t plus pi by 2. Therefore, I could rewrite this equation for current as I is equal to I0 sin omega t plus pi by 2. Therefore, if you are taking this expression for current, it is in terms of sine. Therefore, we have to, or therefore we could draw the phasor diagram. And the phasor diagram corresponding to this one, it will be, I have to draw the axis first. Let's draw the axis over here. This is our axis. Then initially we are drawing the voltage phasor. It's a sine function, and I am drawing the voltage phasor like this. This angle is omega t, and the current, in this case the current is leading by an angle of pi by 2, since it is sine omega t plus pi by 2. And since the phasor is rotating in the anti-clockwise direction, therefore current is leading means we have to draw current at an angle pi by 2 with voltage, and it should be drawn in this quadrant since it's rotating in the anti-clockwise direction. This is the current, and the angle between voltage and current, it is pi by 2. From this phasor diagram, we could clearly understand that the current is leading voltage or voltage is lagging current. And next is the wave representation. If we have to draw the wave representation, we have to draw the sine wave, that is voltage is a sine function. Therefore, I'm drawing the voltage wave like this. This is our voltage wave. Then look clearly, current is a cosine function. If current is a cosine function, we all know the expression or the wave representation of a cosine function. It will start from here, it will move through points like this, and if I am drawing the wave, it will be like this. The red one is the current wave and the blue one is the voltage wave. In the similar manner, let's have the next circuit, that is a circuit like this. This is an inductor which is connected to an alternating power supply. Inductor is having a self-inductance of L and it is connected to an alternating voltage of V is equal to V0 sine omega t. In this case, we have to derive an expression for current, and that expression should be in terms of voltage and inductance. Therefore, we have to recall an expression which is having a connection between voltage, inductance and current. From our Faraday's law of electromagnetic induction, we know induced EMF is equal to L into di by dt. But in this case, the EMF is given, or we could write V is equal to L into di by dt. Some of you may have a doubt, that is, there's a negative sign over here. No, we are not dealing with the induced EMF. We are dealing with the given EMF in this case. Induced EMF, it is minus L into di by dt. Therefore, I could write V is equal to L into di by dt. Then what's di? Di is equal to V dt divided by L. We could substitute for V as V0 sin omega t. Therefore, V0 sin omega t dt by L. Then di is equal to like this, means in order to take or not to get I, we have to integrate this equation. On integrating, integral V0 by L sin omega t dt. In integration also, we will take the constants out, that is V0 and L is constant, V0 by L is taken out, integral of sin omega t dt. As we all know, integration, that is integral of sin omega t dt, it will be minus cos omega t by omega. Therefore, I am substituting for current as I is equal to V0 by L, integral of sin omega t dt is minus cos omega t by omega. It could be written like this, that is V0 by L omega into minus cos omega t. Then in this equation, V0 by L omega, this is a constant, or this is the maximum value this current can obtain. Therefore, in this case, the peak value of current, let me write it over here, the peak value of current I0, it is equal to V0 by L omega. This is the expression for peak value of current in an inductor only circuit. Therefore, I could write the equation for current as I is equal to I0 into minus cos omega t. Why I am retaining this minus cos omega t? It's for drawing the phasor diagram. That is, by having an equation for voltage like this and an equation for current like this, can I draw the phasor diagram? No, it should convert, or we should convert this into a sine function. Therefore, I could write minus cos omega t, it is equal to sine omega t minus pi by 2. If you are thorough with the trigonometry, there's a relation like this. Okay, then I am writing this equation, that is I is equal to I0 sine omega t minus pi by 2. Therefore, we are having an expression for current like this, from which it is clear that the current is lagging by a phase angle of pi by 2. In the capacitor only circuit, the current was leading by an angle of pi by 2. In the inductor only circuit, the current is lagging by an angle of pi by 2. And then On drawing the phasor diagram, we are marking the axis initially. Then let's draw the voltage phasor. This is our voltage phasor. This angle is omega t. And in this case, the current is lagging. Since the phasor is rotating in anti-clockwise direction, current is lagging means the current, it should be drawn over here. This is the current, and the angle between voltage and current, it is 90 degree. Then from this phasor diagram, it's clear that the current is lagging by an angle of pi by 2. Wave representation. On drawing the wave representation, let's draw the axis first. Then as usual, we'll draw the voltage phasor. It's a sine function. Therefore, the curve of voltage will be sine function. It should be like this. Then as you can see, current is a minus cosine function. The cosine function will start from this point, means minus cosine function, it will start from this point. Then its paths will be like this. Therefore, if I am drawing the graph, we will get the graph for current like this. The blue graph is, the red graph is the graph for current, and the blue one is the graph for voltage. This is the phasor diagram, and this is the voltage representation. Now we are clear that what's happening if an alternating voltage is connected to a resistor only circuit, capacitor only circuit, and inductor only circuit. In a resistor only circuit, the current is in phase with voltage. In a capacitor only circuit, the current is leading by an angle of pi by 2. In an inductor only circuit, the current is lagging by an angle of pi by 2. The peak value of current in resistor only circuit is I0 equal to V0 by R. The peak value of current in capacitor only circuit is I0 equal to CV0 omega. The peak value in inductor only circuit is I0 is equal to V0 by L omega. Hope it is clear.